Hi guys, this is Miss Scott here. So today we're going to talk about two new types of quadrilaterals called trapezoids and kites. And we're going to learn some properties about those. So the first type of quadrilateral that we are going to learn about here is called a trapezoid. And a trapezoid has exactly one pair of parallel bases. So the parallel sides, yes, we do refer to the bases. So this is a base on the top and on the bottom. And it's only got one pair of parallel sides, as you can see from the picture here. An isosceles trapezoid is a specific type of trapezoid, so it's still got parallel bases, but in this case, these legs are congruent. So that's another term that you need to know about. In a trapezoid, these on the side are called the legs. So the other two sides that aren't the bases. We'll get to this later, but just for now, know that the mid segment of a trapezoid connects the midpoints of the legs. And we'll refer to that a little bit more in Theorem 8.17. Lastly, a quadrilateral that has two pairs of consecutive congruent sides is called a kite. So we know these two sides are the same and these two sides are the same, then we call that a kite. And we are going to learn some properties about all of these terms today, starting with an isosceles trapezoid. So let's take a look at our first theorem. Okay, so in Theorem 8.14, we have if a trapezoid is isosceles, then each pair of base angles is congruent. So in this picture here, if this is an isosceles trapezoid, it turns out that these two angles and these two angles are the same length, so I could call this y degrees and y degrees. And these two obtuse angles are also congruent. So this is x degrees, and this is also x degrees. Let's use that in an example. Notice that in this example, they tell us that this is an isosceles trapezoid. So if angle A is 97 degrees, angle D must also be 97 degrees. Well, now we need to figure out what we have left over for angles B and C. If you recall from an earlier lesson, in a quadrilateral, the four angles always add up to 360 degrees. And then we can subtract the 97 degree angles for A and D. If we do that, we're left with 166 degrees. And then we have to cut that in half to give us those two remaining base angles, which will both end up being 83 degrees. And you can test these answers by adding up all four angles and just double checking that they do really make 360 degrees. Let's look at another example, another theorem involving an isosceles trapezoid. So if a trapezoid has just one pair of congruent base angles, then it must be an isosceles trapezoid. And we'll look at a picture of just that in a moment here. Let's name this A, B, C, D. So if we have a trapezoid and we know these two angles or the top two angles are congruent, well, then we can say ABCD is an isosceles trapezoid. Okay, so you only need to have one pair of base angles for that to be true. Another theorem about isosceles trapezoids is an if and only if theorem, so remember that works both ways. And it tells us that if a trapezoid is isosceles if and only if its diagonals are congruent. So if you would measure these two diagonals' lengths, let's just call this again A, B, C, D. So if AC is equal to BD, it's an isosceles trapezoid. And also, if it's an isosceles trapezoid, you can conclude this, that AC and BD are equal. All right, now our next theorem deals with any type of trapezoid. And this is when we're going to talk about that mid-segment. So the mid-segment of a trapezoid is parallel to each base, and its length is actually half the sum of the base lengths. So let's use this picture here to explain that a little bit further. So let's call this A, B, C, D again. And if we would call this midpoint here M, and this midpoint here we'll say is N, if we connect that mid-segment, this base and this base are parallel, and MN is also parallel to those bases. Now, if you want to find the length of MN, what you can do is take half of the length of AB plus the length of DC. And we'll use that in our next example. So here, if you look at example 4, we're going to find the length of MN in this trapezoid. We're going to take half of the base of 21 and the base of 17. So in that case, we end up with half of 38. And half of 38 is 19. All right, so that's how that theorem works. You can also use it to set up equations. So in example 5, we can say that 17.1, the length of the midsegment, is equal to half of 2x plus the other base, which is 8x plus 3.2. Now there's a few ways you could go about solving this. What I'm actually going to do is multiply both sides by 2 to get rid of that 1/2. So this 1/2 and this 2 will cancel. And if you double 17.1, you get 34.2. And now what we have left over on the other side, we can combine 2x and 8x, giving us 10x plus 3.2. And let's go ahead and subtract 3.2 from both sides. So these will cancel. And we end up with 31 equals 10x. And notice if you divide both sides by 10, you end up with 3.1 for our value of x. Okay, so you can use this formula not only just to find lengths, but also to find variables. All right, so our last topic of discussion is going to be a couple of theorems involving kites. So our first theorem deals with the diagonals of a kite. If you have a kite that is a quadrilateral, if you draw in these diagonals, and this is just a sketch, but you should probably notice something about this kite's diagonals. It appears that they meet at 90 degrees, and that's true. The diagonals are perpendicular. Okay, so it actually divides a kite into 4 right triangles, and then you can use all of the theorems and formulas that we talked about in an earlier chapter involving right triangles. And that's what these 2 examples here are going to involve. So let's start out by just finding the measure of angle VST. So if we go from V to S to T, that would be this angle here. Well, if you recall, this here is a right angle. So let's just look at that right triangle right here. Okay, so if we would just focus on that right triangle, we know that this length is 8 and this length is 9. And I'm trying to figure out this angle here. And this was at S. So if you look at this 9 is opposite angle S, and this 8 is adjacent to angle S. So if you remember, that means we can use sine, cosine, or tangent. In this case, opposite over adjacent means that we can take the tangent of angle S has to be 9 over 8. So remember, to get S by itself, we have to take the inverse tangent on the left. And if we do that on the left, we have to do that on the right. So this inverse tangent cancels out this tangent, and we're left with angle S equals the inverse tangent of 9/8. And if you plug that into your calculator, you'll get about 48.37 degrees. So that's just this angle right here. So to get the whole angle VST, what we will do to find the measure of angle VST is take that 48.37 degrees, double it, and we will end up with 96.74 degrees. So that's going to go right in here for example 6. Okay, now to find UT, I'm going to erase what we've drawn so far on here so we can start over. So the length of UT is right here. And if now I just focus on this right triangle, remember this is still a right angle here, let's see what we can set up. So I'm just drawing that lower right hand right triangle, where this is 7 and this is 9. And I'm just going to call this length of UT x. So if we have a right triangle, we can set up the Pythagorean theorem. X squared is equal to 9 squared plus 7 squared. And 9 squared plus 7 squared is 81 plus 49, which is 130. So if x squared equals 130, what we can do now is take the square root of both sides, and we will get x equals, the square root of 130 is about 11.4. All right, so yeah, sometimes we will still throw a few things in about right triangles. Your last theorem in this lesson, again, is dealing with kites. And if you have a quadrilateral that is a kite, so suppose we have this kite over here, it turns out that exactly one pair of opposite angles are congruent. And it's probably pretty clear to see just by looking at the picture that it would be these two angles, the opposite ones, that are congruent. All right, so let's use that on these two examples, example 8 and 9. First of all, to find the measure of angle M. So I notice that M is opposite K, so those must be congruent. So let's call this and this X. They have to be the same. Well, if you remember, all four angles in any quadrilateral, including kites, add up to 360. So if we take X plus 50 degrees plus 60 degrees, that must be 360 degrees. We can combine like terms. We have 2x. 50 plus 60 is 110 equals 360. And if we solve this for x, we're going to subtract 110 from both sides. And we'll be left with 2x equals 250 rather. And dividing by 2 will give us 125. All right, so that tells us M is 125 degrees and K is also 125 degrees. All right, so use these 6 theorems in today's lesson to figure out any missing lengths and any missing angles in isosceles trapezoids, mid-segments of trapezoids, and then missing angles and side lengths for kites. And if you guys have any questions, just be sure to ask me when you can.